Hey, good morning, everyone. Merry Christmas and happy holidays. Let me know if the sound is all right, everything is good. Meanwhile, I'm gonna open the hopefully it's all good. Gonna wait for your comments, whether we are live or not. I know there's not gonna be too many of us today because it's Christmas. I know everyone's spending their time with the families. I'm really happy that you do. But I just wanted to make last stream in the year, and why not? I'm gonna watch it in the record. Alright, a little Prosecco open, and then we're gonna start coding. And we're gonna use some trees today, implement other trees. So actually, the obvious thing to do in the Christmas is to code a Christmas tree. But then, well, you're gonna see yourself. So I had this website in mind for a while. It's not really complicated, but it has some interesting stuff related to the three.js, shaders, into some math. And that's what we're gonna do today. I'm gonna switch the screen and I'm gonna cheers. Echo. So now we can start. Yeah, no, just let me know where you're from. At least say something because it's gonna be a real, comfy small stream today. I had a doubt whether I should stream actually because everybody's celebrating. But then, yeah, next Sunday is in the next year already. Hey, David. And by the way, thank you everyone for supporting me during this year. Even if you're watching the record or watching live. Anyhow, thank you for watching and thank you for supporting me this year. Might have been the hardest years in my life actually. Not due to the webgl reasons obviously, but still. Still happy to see you and Merry Christmas to everyone. Yeah. Switching the screen, this is the website. I'm gonna put the link in the chat. And it's been a long time because I like this kind of partitioning, the division, the split of the rectangle to rectangle. Let's see how to make it and let's see how to animate it in this weird funny way and to texture it in this funny way. Yeah, Merry Christmas to Croatia too. Right, so the first thing that comes into mind, and this is actually the reason I'm making the stream about this one, is this the thing is looks like Kd3 because Kd3 is k-dimensional trees. Kd3, you just Google Kd3, the images, you're gonna see all the stuff like that. You could see all the partitions like that. So usually the most beautiful, randomly chaotic beautiful is actually the Kd3s. And they could be actually implemented in 3, 4, 5, any kind of dimension. That's why they're called k-dimensional trees. And well, we're going to implement them in 2 dimensions today just to create this partition. And then let's see. I'm just going to show you how you could use Kd3s to get those rectangles because it's not obvious. And you could also use it for the generative art and whatnot. Because Merry Christmas to Canada. Oh, that's got to be pretty late now in Canada. All right. Depending on the part of the Canada. And what big country you have. What onk do you do? All right, let's get started. First of all, I'm gonna start with a 2-dimensional tree, and for this, I'm gonna use the canvas sketch. Have the base, basic, duplicate, tree. I'm gonna use it tree. But first of all, let's draw this 2-dimensional rectangle partition in rules. Christmas Netherlands. Oh, call me my idol. Be your own idol. You are the best. Okay, so we have the something running. This something running. I have the basic template with canvas sketch, which is optimized for the Instagram size, and then I called this one tree. One up. Let's code a simple Kd3 first. A lot to do during this stream. Hope I'll have time to drink Prosecco. A lot of coding involved here. I don't know, I should have made it an easy one, but okay, I'm gonna first delete some stuff that I wouldn't be needing. This is just a simple canvas sketch template, which is, I mean, you could have used anything. This is just the basic thing that I used to draw something on in Canvas, because it has some stuff built in already. It has a render function, which drawing a green rectangle right now, but no, I don't really care. So first of all, we need the Kd3 npm package, Kd3.js. Yeah, how it's called. Probably could go to the npm straight away just to get the line to implement it. They don't have it. That's fine. That's fine. Just gonna do gonna get that one. Let's see what's inside. I should see the chat as well. I gotta actually see it on the other screen better. Merry Christmas to all of you. Tokyo. Merry Christmas to you. Thank you, Yukitanabe. Whoa, 4 a.m. 4 a.m. That's crazy, man. That's gotta be winter. Like we have like -10 at least, I guess. I presume. So we have this simple green rectangle, which is boring. Now we have to have, to have a KD3, and well, the only reason those KD3s exist is to actually make the fast nearest neighbor search. Meaning, like you have 1,000 points and you have one random point, and you need to find the closest point from all of the 1,000 of those points to this one, to the target point. And well, you could just loop through all the thousands of points. This is also it's a perfect thing to do. It's just not the most efficient thing to do. So the most efficient thing to do, one of the most efficient things to do, is to use KD3s. So you partition all the, like you have the bounds, like the maximum and the minimum bounds for all the points, and then you partition into those like branches or leaves, because this is a tree. And trees mean that each rectangle has two more like rectangles inside of it, at least, or none. Oh, to Ukraine too. Merry first Christmas, because here in Ukraine we celebrate two Christmases. I'm not Catholic, I'm Orthodox, I guess, but we still, regardless of your religion, we celebrate two Christmases here in Ukraine and two New Years. That's how it works here. Because why have one Christmas and one New Year if you can have two, right? Anyhow, so we have this partition, and when you look for the closest point, this is actually like the thing visualized. You don't have to look in the gray rectangle anymore. Like half of the points, you don't have to compare the distances. And this is how it makes it more efficient. I mean, I wouldn't go deeper into the KD3 algorithm. Maybe we will use it in some other streams for something and to compare the efficiency and performance, but not in this one. So you just have to know that KD3s are beautiful, and they are trees. And trees, Christmas, this is the reason I'm doing this. So these kind of trees, right? Does it look Christmassy to you? It does to me. So holiday vibes. All right, let's implement the KD3s. First of all, we have to have a bunch of points. Add points array. Then we're gonna have the loop. Let's say I don't know, 5 points. So I'm just gonna loop for them and add some more points in my array. We have the width. For now, it's Instagramish width, like 1080 pixels. Y, and then points, push, points. So we have points. And we could actually draw them immediately just so we see them. And then context. y, I don't know, 30, 30. We have to see something now. We don't see something because we drew the green thing over the every true. And well, the white background is the best one. We have to switch fill style then. Yeah, so we have the points now. And it's just 5 random points on the screen. Not too many things. Oh, finding neighbors now. Oh, to Minsk too. So we still have some pretty good geography, even though we have Christmas calendar. Okay, so we have the points. Now we have to create the Kd3 partition and visualize it somehow. Let's do that. It's not going to be enough to build a 3D thing, but it's a good start. So first of all, I have to initialize the tree. So I have to do the tree. It's going to be Kd. And by the way, I actually cancel logged the object that we have, and we have the binary heap and Kd3. Only interested in Kd3 actually. It's going to be Kd3, Kd3, and then what else? We have to put some parameters here, and then it's going to be a couple of those. We have them. Kd3. So first of all, it's going to be points, then the distance function, and this should be just the Euclidean distance function. Implement this one. Function distance between the 2 points in my tree. So this already like shows you that it could be anything. It could be 3-dimensional, 4-dimensional, anything, as long as you have some distance function. AB, and let's gonna be a x minus y same y, and then I could just probably on the square of those, right? Yeah, so it's going to be just the length of the vector between them, and it could be either negative or positive. Even Julua, I have to check how to read that one. Long time no see. Mr. Sebiton. Okay. So it's going to be x2 plus 2, and that's going to be a distance. We should actually take a square root out of this one, but I don't think that's important. It's going to be just used to compare the distance between the points, not to actually use the distance numerically. So then we're going to have here. So first of all, we could actually initialize it empty, or we could just use the points. Sometimes it's actually pretty cool to initialize it empty and to add points along the way. And this is what people usually do with Kd3s to animate them. And we distance function, and then the dimensions. Dimensions should be they look like those dimensions. The x and y. This y, and then you could actually, first of all, we could push points to the points array, but then we could push them to the tree. So it's tree, insert point, and then distance should be placed before that. So this is the only thing that makes sense for now. We have the distance function, we have the points array, we create random points on our screen, and then we should see something on the tree. See what's going to be in the tree. In E. What exactly is undefined? E is undefined. Like I just initialize it. Would it be undefined? B is undefined. That's probably Kd3. So I have Kd3 and then Kd3. Did I miss some typo here? Let's take it slow. Oh yeah, it's new. Thank you. Yeah, it's an object. Right. Is that all right? So now we have the tree, and inside this tree, well, there's some things that to find the nearest neighbors, remove the stuff from the tree, but then we have the root, which is the actual tree, and in the tree we have the left and the right. We only have, it's like a binary tree. We only have left, right, and the actual point. And what you see here is actually like left, right, but those left and rights are not the special kind of left and right, because they could be top and bottom as well. They're going to change places later on because we're going to change the axis. Anyhow, each tree it's an abstract left and right. It's like the first and the second. And then we have the left, which has the same properties like the object, meaning the point coordinate, and then the right, and then the left is null. And this means that there's an empty square, empty rectangle over there. So this is why it's called a tree, because we have the first root branch, like the root of the tree, and then we have the left and the right branches. We have only right branch for now, and then the right branch has another branch, and so forth. So we have like a tree. You have it here visualized somewhere, probably. Yeah, this is how it looks like. Each point has a leaf, another branch. This is how it works. Now we have the tree. Now it's time to visualize this tree in our canvas 2D. To do this, I'll probably copy paste a little bit of the code because it's just too many like indexes of the points. And I think in some code pen, Kd3, CodePen, in this function, take it. Yeah, so that's some nice algorithm, but this function is not going to be enough for us to build a 3D yet. It just will simplify a little bit thing to do. So they have this function which renders the node and the bounds. So let's do this. Inside here, I'm gonna create the function draw rectangles. And here I create the function for rectangles. It gotta have some parameters, and this is gonna be the parameters, node and bounds. They call it render, or call it draw rectangle. We're only interested in rectangle. So if node null, it just return. I don't need that actually. Explain it a bit later why I don't need that. Let's just copy paste everything. So they have the context. Let's also put the context here. So it's context, node, and bounds. And here also context. And then the initial parameters. The initial parameter is going to be just tree root, which is the root node of my tree, and then the bounds. And the bounds is going to be something like this: 0 width and 0 height. So this is just a square on my screen, like the coordinate system that I have, the maximum, the minimum bounds of all my rectangles. All right. So we have the function here. Now I have to implement this function to fix it probably. So we have the context, node, bounds. Instead of, I'm just going to fix it. They run this function recursively, so I have to run it again here. Text for the left and the right node. So each time it just goes through the node and then finds its children and goes through the children. So you have to run it only once, and it will go through all the tree, just going through all the branches until the final leaves and the final branches or elements, or how do you call them on the trees? Hey. All right, so I'm gonna fix this one a little bit. Maybe ctx still fix less of the parameters. So this is why I didn't want to implement it myself on the stream, because you have to write the correct numbers, and this gets a little bit tricky when you drink Prosecco. I mean, you could do that, but I don't want to you spend the time me figuring out the broken index somewhere. So essentially what this function does, when we get the root node, we create the left and the right bounds. And remember, those could be top and bottom, but this actually doesn't matter. And then, well, some context drawing stuff. what's important then, depending on the dimension, and I would remind you that this whole Kd3 has a dimension thing. So dimension is either 1 or 0 because we only have two dimensions, x and y, because we stated it that way. So the left and right is always either 1 or 0. So now left and right dimension is 0, but if we go deeper, dimension is going to be 1, 0. It's going to be changing places. So each time we partition the square or rectangle or the space with the points, how do you call the partition this? Each time we split the space, we split it in the, like, on the even steps, you split it on the vertical axis, on the odd steps, you split it on the horizontal axis. Or vice versa, it doesn't matter, we just change the dimension. And this is why we have to have this conditional thing, just to state which dimension are we going for. And then what we do here is actually move to line 2, and then we have the fill rect. I'm gonna do the stroke rect. So we have the rects on the screen, and we draw rectangles. And this alone should actually hopefully draw something. Return outside the function. Return. Did I have this return? Did I mess something up? Maybe I think I copied the wrong bracket here. Opts is not defined. Okay. Fix this function in a second. Can't read properties of null reading dimension. And this means if node dimension is 0, that's why we get this error here. Okay, so we're just gonna do so I think each node has dimensions, but when we run on the last node, on the null node here, so this is where we have to do this. So if node left, if we have some node left, node right. So we only run the function if the node right actually exists, if it's not a null. Because if we run it on a null object, they don't really have any dimension, any properties of the object, so get an error here. Right, now it's good, now it's all black. We have the stroke here. See, so now we have the algorithm working. So now we have the stroke rect for each of the rectangles now. Not actually for each of the rectangles, because you could see that we don't have it for the last rectangle. You could at least see it here. We don't really have another border right on this part of the screen. Well, we have the rectangles here, but we don't have them there. How to get all the rectangles from the Kd3 algorithm? We don't actually need all this stuff. I mean, only the dimension setting. But what we could do here is, if there is no node, I mean, if we are on the last leaf, we should just save it as a rectangle. And this way, we're going to go through all the rectangles in my algorithm. So here, I'm just going to do the console log left bounds. And here, right bound. So now we have like 1, 2, 3, 4, 5, 6 rectangles here. And I have exactly 6 dimensions for my rectangles. And we could go through them. And those are not actually coordinates of the points of the rectangles, but it's like the maximum x, the minimum and maximum x axis, and then the minimum and maximum y coordinate of the rectangle. So this way we could actually store all the rectangles. Right. So I guess we are ready to move from the two-dimensional Kd3. This is how you drew it, and this is how you could collect all the rectangles. We are ready to move to the 3D space. So let's go to the tree. We're gonna make tree with a 3.js. Okay. one up. Run parcel. Let's see my template and drink a little bit echo. Yeah, Merry Christmas to all the newcomers. Happy to see you. Have a small stream, but we are the good ones. I mean, we are the best ones. We're not that much better from you watching in the record, but we're doing it live. All right, so we have the template. Now we are ready to create this partition here. So what I would do, I would just copy paste this function, like this whole thing here, the distance and all this stuff. This is what we need. I'm gonna remove the, probably remove the two-dimensional canvas references from my JavaScript. And then we're gonna, and also need, I will also need to import the Kd3 from the npm. I don't need to create anything yet. I'm gonna copy paste everything I've got, and I'm gonna remove all the context references. Need to draw anything yet. Not actually drawing anything, to be honest, but still. So now I'll have some kind of width equals 1, height 1, so we have the width and the height variables, and all the numbers going to be between 0 and 1. Yeah. Oh, Manish line. So we have the width and the height, we have all the points, we have the rectangles, we have to run the function. Run it like this. And maybe we could do something like let rects, and then here push, here push, and then just gonna console log. Of course, you could refactor that to more beautiful JavaScript code, but yeah, rect, and we have to have something like 6 rectangles probably there. Let me check if I'm doing everything right. Remove the context. Need it. Also, kudos for the original author of this function, namespace Jargonaut. And then, do we have here? Console log rects. Saved everything. Kd3 is not defined. Yeah, obviously. Obviously. Let's wait for the parcel to install it. Right, now we have 6 rectangles, and every single item consists of 2 bounds of every rectangle. So now we are ready. We don't see anything, but we are equipped with all the information to create the actual animation. So let's do that. Let's do that. Do just that. So 3.js has a shape geometry thing. It's almost like a canvas 2D, but different. So we're gonna go through all the rectangles, rects for each R. Then I'm gonna create the shape move to. And then we could do something like line to. Oh, not as extrude settings. Could be actually fun to leave bevel enabled. Maybe I'll do that. So the depth it means the z depth. Let it be 0.5. I'm gonna enable it later on. Steps 2, geometry. Gonna be just shape with the settings. Then we extrude geometry with those settings. And then we have the mesh, and we could add this mesh. Mesh func, basic. So we gotta see something now. Format that one a bit. We gotta see something now. Well, there's something. Not really looking cool. Anyhow, so inside of each of those rectangles we have the bounds. Now it's time to put those bounds into this shape thing, because we could like be one to show you that it's working. I'm gonna create some shape like this, because we have steps set to 2, we have like depth of 2, I don't know, 3 vertices along the z-axis. All right, so we have the thing. So now we have to put correct coordinates here. So first of all, we're gonna start with r 0 0. This is gonna be the start. This is gonna be the x-axis, because the first array of the bounds is the x-axis. Then we need the y-axis as well, so it's gonna be ry r1 0, because we start with the first, like the minimum y and the minimum x. And then, well, oh well, not something that you want to do, you want to code when you're a little hangover, but that's, you gotta do what you gotta do. So okay, this is gonna be like this. So the y-axis stays the same, we just go in from left to right along the horizontal axis. So the first two are right. Then the next one's gotta be, we gotta move along the x-axis. No, we moved actually vertical, because the x-axis stayed the same. Now we gotta move along the on the y-axis. No, we actually moved horizontally. Oh, I hope I should just put the random thing here to just work out. So these, each of those should be here just 2 times. Okay, let's see if this one works. And this one actually works. What are the chances of putting random numbers there and getting this partition? So probably the depth should be a lot less than that. Let's enable bevel for a second. Yeah, it's gonna be crazy, because it's gonna be like a, you know, kind of a rounded thing to do. This now it's gonna be a little rounded. I mean, why am I doing this even? Right. So we only have this. I don't need several steps. Right. So we actually have all the recs here. Next step is to put an image there. So let's just find some Christmas tree. I need to have a big one and the squarish one, because I use the square. I started with the square. I think this one will do. It's 3000 pixels wide, so should be fine. Getting closer. Now let's get to the shading. We could also, each time we're offset all of those things, I could just subtract. Which point do I subtract? I could subtract here. -2 and so it's gonna be centered now. Yeah. So we centered all the stuff. Ooh, in a dirty way. Maybe this is the best. So what I want to do now, I want to shade them all. I want to put an image there. So I have the image open for me. So weird about this. Why would you even, like, what's wrong with this image? Or is it some copyright protection stuff? In How did it save it like that? All right. Anyhow. Oh. Those are the mysteries of the internet. So we have the Christmas tree. Well, if you have better one, you just send me in the chat. Maybe we'll upload better image. All right, so we have the image. Let's call it tree. So we have all sorts of trees here. And the folder is also called tree. Good luck finding this one. Okay. Tree JPEG. Now I need to import. I don't need two-dimensional thing anymore. Using parcel, I need to import all the assets. And the new parcel, they changed that. I'm still using the old parcel. Should update at some point. Tree image, and then tree image from tag, and then I'm going to use shader material now, not the basic material, but the shader material. Where do we have it? Right here. So we're loading the texture here, and then I'm gonna replace the here. We're gonna replace what? Place the material. Actual this material. I have this material, and you could see that we even have the some kind of UVs here. They're not right as far as I see, but something. We got something. Now we're gonna go to fragment shader and just try to use this image. And the uniform. And let's output it now. So yeah, the UVs are not right, but I think in this particular case, I could just do something like the vec2 new UV equal UV maybe plus, and just in UUVs. They just shifted exactly 0.5. You don't need to do that. You will have to calculate your own, I guess. But because I know the numbers, new UV. Hey, Merry Christmas, Jordan. All right, so now we have the tree. It's kind of on a box, and I would just remind you that this box is actually a lot of boxes, right? A lot of boxes. So it's going to be the next step. Next step is going to be shading. Let's shade it so it looks beautiful. And also shade it in the Christmas palette. I also need the Christmas palette. Which one should I pick then? One looks more Christmas. Well, I guess this one will do. So I'm just gonna create the palette. Hope I spelled it right. Just a little boring part. Got 4. Last one. All right. Map. See. Just to have the three.js colors here. Right. Here are the colors and the RGB format already ready to be used in the uniforms. What else? What else? What else? Now I would actually want to use some different shading on the border. So how do you use it? First of all, I will need normals. I will use a trick which is only good for the rectangles, but still. So normal, I need to use normals. So, and What? Yes, I declared the normal. Right. We could also output this one. Kind of trying to do this fast, right? So we have the normals, and depending on the direction, we have the different color because normal has 3 numbers, color has 3 numbers. Right, we have normals now. What we could do now, because we have normals, meaning directions, and we have the dot product, which is either 1 or 0 when everything is perpendicular or orthogonal or in the 3D space, we could do this. So I could do this. Front side, then side, just side. Gonna be let's say green, R G B, and then we have the, let's call it color. This front side doesn't really do the job of explaining it. Okay, side color, and then would be mix between the front color, side color, and some kind of coefficient which is different depending on the side. So we could do float side equals 1. It's going to be all we have 4 numbers. It's going to be all green. If it's 0, it's going to be all image. Right. So now this side is going to be equal dot product between normal and what? And the vector pointing towards the camera, which is z have to be 1. X, Y, Z. Right. Because like when the vectors are pointing in the same direction, the dot product is going to be just 1. I mean 2 unit vectors. And when the vectors are perpendicular, and we only have the vectors pointing in the same direction, all the perpendicular vectors, because all the normals are going to be pointing to the top, to the left, right, and 2 of them will be going to be pointing towards me and from me. So probably this should do the job. Yeah, but it should be the other way around, right? So I mean, change the places. Now we have the sides shaded in a different way, but we have the back side still green. And why is that? And that's because we don't only get the 0 and 1, we also have the -1 when the vectors point in the opposite directions. And to fix this, I'm just gonna take the absolute here. So yeah, now we have the image on both sides. We have something on the shade on the other side. And instead of side color, I could actually use something different now. I could do sign from the V position. Do I have V position actually? I don't have it yet. And V position X multiplied by 50. Maybe? No? And this should be 4-dimensional actually. Yeah, we kind of have it, but only on the one axis. So to fix this one, I'm gonna add all of them. Let's see what's going to happen when we add 2 of them. We're going to have the stripes on both sides, but when we have the last one, we're going to have it on every single side. And of course, they are not yet beautiful. Yeah, hello to Kenya and Ethiopia. Whoa. Wish I would travel all those countries someday. All right. So now we have the sides shaded in a different way, and that's all thanks to the dot product and the absolute product of the dot product. Right. How to fix this sign function also? So let stripe equal this. The sign actually goes between -1 and 1. What I want here between 0 and 1. This. Yeah, so more equal stripes, and then smooth step. I always forget like what the order of the numbers here. I'm right. Yeah. Now we have the perfect stripes going on all of the sides here. Perfect. Let's go to the animation, finally. Let's go to the animation. First of all, I'll need something to enable settings here. I also need an array of my meshes. So when I create the meshes, let's also create and let's put the mesh here. But I need some random offset for each of those meshes. Because for now they will be animated at the same time. I need some random thing so they have it. So usually the way to go is to use user data inside the mesh object. And path random. Right, now do the animation. So inside my loop, every loop should probably do that only when the animation runs, but anyhow, for now, it's all right. So we have the mesh. And let's for now change the z coordinate of the mesh. Because the progress is changed between 0 and 1, and I want my mesh in the end to be in the same spot that it used to be, I could do this. Let's sine phi multiplied with this settings progress. Let's see what's going to happen now. They're all being animated at the same time. So now this is where the offset should play its role finally. And each of the meshes should have its own offset. It's going to be. And then I'll need the clamp function. I don't want to import the clamp from the npm. Write it myself. So we have the clamp, and because I only want my numbers to be between 0 and 1, and first go the actual numbers. And because we actually did that in a couple of other streams, I will try to write the formula here. So it's going to be this settings progress minus 0.5 multiplied with m user data offset and divided by 0.5. So this is the just this kind of staggering animation. Let's see what's going to happen now. Nothing changed because we're not actually using this local offset yet. Instead of this set in progress, I'm going to use this. And I think this is too much. Yeah, getting there, right? Now I can actually put more points in there. I only have 5. Let's put 16. Right, and cool now. Of course, you could implement any kind of physical material with shades, arrows, and everything you would like to do. So now we just did this. All right. So now up to the next part, we only need the rotation to do. I'm going to be ready. Well, thank you for asking. I don't know how am I doing. Hope I'm good. I'm not sure after this year. Hard one. I just hope it's going to be not as... It's not going to get worse. All right. Rotation. I need to implement rotation. So this is where we're gonna probably stumble on a problem. Rotation x equals same local offset, and because we're just flipping them, it's just the math pi. But well, I mean, this might be actually even cooler than the previous one, right? What we could do now, because I had this palette had this palette, Christmas palette. Let's implement it actually. So instead of using this material, I'm gonna create new material. Is gonna be this material clone, and inside my material, I'm gonna create another uniform new color. This could be actually implemented with the attributes, but I think I'm just going lazy, easy way. And it's gonna be empty. 0. Let's set it to 0. The first color, and then here, new material. I'm gonna use the new material here, so it should stay the same. Just should set the texture again, because texture is not being copied when you clone. And maybe I'll just set it. And then new material. New texture. And it's gonna be palette, and then math floor, math random, multiplied by the palette length. So this way we just pick in the random color from the palette, right? So now we have the color is back. Now we have the color back, and now I want to implement the color on the other side. So I want my whole shape to have a different yeah, of course we're gonna fix the pivots. I hope we're gonna have time to fix that. I want each of my squares to have a different color right now. That's what I'm trying to do. So uniform 3 hue color. Test things out. Yeah, we have those. It doesn't look that Christmassy to me, but still. Now what we have to do, we actually took the absolute from the side, because the only thing that we know the difference between those sides in terms of normal and dot product is it's +1 and -1. What I could do here, I could do like float back and what? Back and front. Gonna be equal to this same dot product +1. This now between 0 and 2. And now I just multiply it with 0.5. This one between 0 and 1 now. And I could use front color. Instead of front color, I'm gonna use the tree color. And front color is gonna be mix between tree color, hue color, with the back front variable. And then in the end, we're still gonna mix it with the side color as well. So let's see. Yeah, it actually worked. It should be the other way around. Right. Still doesn't look that Christmassy to me. Maybe we should make more of them. Should be more green. Should be more green ones. That would make it more Christmassy, but it's some reason it's. Which ones were the green? The green were the first ones. Maybe I just command the get more green. Yeah, kind of Christmas, I guess. Still pretty cool this way too, right? We kind of implemented this animation already, so just gonna do a couple of small touches and we're gonna finish this one. What we could do here, how to rotate them on their own axis. Well, this is a hard one. Not really a hard one, but it will require us to change a little bit the algorithm, because for now all the geometries are positioned exactly in their points in space. So it's not like the box meshes are positioned. No, each mesh position right now is at 0.000 actually, even though they are like separated in space, but they are separated because their vertices have different coordinates, not because the mesh has a different coordinate. And this makes it a little bit difficult because we will have to calculate the center of each of those things, and then Merry Crisis, guys. So this is a good one. Merry Crisis to you too. uh, could cry on this one. I don't know if it was intentional or not, but I think this is kind of funny. All right. Um, yeah. So maybe I'll spend like a couple of minutes trying to fix it. If I do it, I do it. If not, I'm just gonna get a lot more drunk and we're gonna have fun. I also have something for the for the finish of the stream. Not for the finish of the stream, but for the end of the stream. Let's try to implement the rotation thing. How you actually do that? How would you do that? Or should I implement it this way? We could also implement them flying from all the different locations. All right, let's maybe do this. First of all, I will need each mesh center in a 3D space. Each mesh center 3D space. Last bit to implement. So X, Y, this. It's actually kind of funny if we change the axis to the Z axis. Pretty cool. Right. Right. Not sure I'm sober enough now, but try this. I draw in rectangles. So I have the for each loop right here. So the Z coordinate is going to be just half of the depth. Maybe 0.5. I just trying to find the center of all these things. And then the X coordinate is going to be plus. And the same for this one. And what I could do next, instead of I should actually translate geometry now. Free buffer geometry. Translate XYZ. So now I could have the center. And then boom. Oh, that's weird. The other way around, probably. Not the all in the center, which is funny on its own way. Right? Somehow not in the center. Why? Should have been in the center. Anyhow. And then I will just position the mesh, each mesh back into their places. Now we have this thing broken because the position are not the global position anymore. That's like a local position of each mesh. But this is not really a problem. They're being rotated now this way. It's kind of funny. Actually need to rotate them the other way, not the. Also a funny way to animate things, but not what I expected. Merry Christmas to Russia too. Okay. So, did I go it wrong? always a little bit tricky to create a pivot for the mesh. You have to create a group. Okay, I have to create another object 3D probably to wrap this thing around. 3.js pivot point. Oh, complicated. There's a function actually to rotate about point. Maybe I could just use this one. Forget about all my troubles. Maybe just this one. Okay, we'll save it for the last resort. 3.js pivot point. There's gotta be some GitHub link from 2012. Yeah, so we have to do this. Rotate mesh center. Mesh position copy data. And I guess we have to rotate the pivots now. Hmm. Something is undefined there at some point. So the pivot. No. Where did everything go? And just save pivot there. So far so good, but I want to rotate pivot. Yeah, that's more like it, but I think it's just the way that we had it before. It's still not right. It's still not being rotated from the center. I wonder why. I guess I... Oh yeah, because we are moving those. Right. So it's gonna be minus something minus width here. It's gotta be. So the first coordinate is actually. I mean, maybe it's cool. Okay, for some reason I messed up the math somewhere. I have to offset the mesh and I have to move something. Here I'm only using English now. Okay, maybe M rotation C. I mean, all the animation are pretty cool. It's just that I not nailed it. It's actually kind of funny. Get this. All right, let's go to the last resort then. We have the function which rotates the object around the point on the axis and theta. Okay, let's try this one. If it doesn't do good, let's just finish this one. Yes, I'm too drunk already. Rotate about point. So for now, I'm gonna change everything. I'm not gonna translate geometry anymore. I'm gonna change it back to used to be like this. And now instead of rotation, I'm gonna rotate about point. What are the parameters there? First of all is the mesh M. Second one is the point M user data center. Let's save this center. Calculated that one. I calculated it somewhere. E. So we have the center. So M user data center. Then the next one is the axis. And the axis should be three-dimensional vector. And the next one is theta, which is local offset multiplied by math pi. And then the last one is point is in world. Okay, could be in world. What happened now? Okay. I guess this is because it applies this rotation iteratively, and when I do this in loop, it's just continually applying this freaking rotation. Well, at least it looks more festive than it used to before, right? Yeah, this function not gonna do us any good because we should have something preserving the original state of the object. Anyhow, I think this one is pretty cool already. No, not this one, particularly this one. This one. I mean, this might be even cooler than that one. And this would be the homework to implement that rotation across the center of the object. So essentially what you have to do, you have to wrap each of those and you have to set the position of the mesh. So the mesh should be like moved from the center to some position, and then you'll have it. Then you'll have it. Maybe I even did that, but I kept changing the direction all the time, and probably just some minus or plus at some point. And I guess it's not too much of Prosecco left, so sorry guys. I think it's pretty cool. And of course you could animate this one value back and forth. This is pretty easy to do with the GSub. But I'm not doing this to get more viewers, Victor. I'm doing this for fun. All right. Plum, plum, plum. So that's it, guys. I guess I have not succeeded in rotating it around the center, but I have this. It's not working actually. I have this. Yeah, maybe I should change the screen. It's working. It's working on the stream. Hope I'm not gonna put fire here somewhere. But I guess it's working. So Merry Christmas to everybody. Maybe I'll spend a couple of 2 or 3 minutes trying to figure out the bug that I have. Maybe not. But I'm glad you've been with me this whole year. You know, we worked through the Kd3s. We implemented it 2-dimensionally, 3-dimensionally, and then just rotating meshes around the point in three.js is actually a little bit of the pain in the ass. So thank you, everybody. Thank you, everybody. I'll put a demo on the Patreon, and thank you, everybody, for supporting me on Patreon, by the way. And I'll put a demo on Patreon with a fixed code where we're gonna use it. We're gonna use it. You can see how to do this. And yeah, Merry Christmas to everybody. Happy holidays. Hope your year will be a good one. I hope you spend it in a good way. And I'll see you in the next year. So thank you, everybody. Thank you, everybody, again. Cheers. Yeah, what else could I do? I kind of ended the stream, but then I still have this thing in my mind. I want to fix it. It's so badly. Maybe another try. I just can't lose to three.js pivot rotational thing. Have the center. Mesh position key. I could also implement it with shaders. Come on, it's gonna be probably the easiest way to do. But I don't wanna involve shaders here. All right, let's leave it at that. Happy New Year, everybody.